All right, this is going to be a bit of a review from Calculus 1 or even, trigonometry, pre-calculus, something along those lines when you dealt with exponents first. So we have a definition up here. For any real number x, we define this y as y equals e to the x, to be the number for which the natural log of y equals ln of e to the x, which is just x. All right, so if you recall the principles for the properties for logarithms, we know that ln of, say a to the b is the same as b ln of a. And here we have an e, so ln of e equals 1. So in this case, our a is e, so that part would just be 1. We have b left over, which is what our x is here. That's just using the formula. The exponential rules are the same. If instead of using e, we use a, it doesn't matter. If we multiply two things that have the same base, then we get to add their exponents together. So for instance, if I have e to the fourth times e to the third, that equals e to the 4 plus 3, which is e to the 7. If you have a quotient, you do subtraction instead. That's same as if you just had, x to the 4th power over x to the 3rd. You can cancel out 3 of them essentially. The last one, this third one here, is the one that usually messes people up a little bit. So if we have e to the 2 all raised to the 3, that's equivalent to e to the 2 times e to the 2 times e to the 2, which is the same thing as adding it's e to the 2 plus 2 plus 2, or e to the 3 times 2. And all of them will end up being e to the 6. So you can look at it as, again, multiplying three things, or the same thing 3 times, because essentially that's what we're doing. And we can either use the first property or just go straight to the third property. So this is why the third property works. All right, so I've got a question down here that is going to deal with essentially implicit differentiation, because we want to be differentiating ln of y. So if you recall from when you learned implicit in Calculus 1, we said we take the natural log of each side, ln of y equals ln of this root x squared plus 1 times root x squared minus 1. And we can break this up using the logarithmic rules. However, what we should probably do is we have, two different square roots. When we multiply square roots together, we can multiply the insides together. So let's do that and see what happens. So this is going to be the square roots of x squared plus 1 times x squared minus 1. Well, if we FOIL those, we get, I'll just put the whole root here since there's just one. So we get x to the 4th, we get a plus root 2, or plus x squared and a minus x squared, which cancel, and then negative 1 times 1 is just negative 1. Now we can use so ln of y is equal to ln of this x to the 4th power minus 1. Well, the square root is the same as taking something to the 1/2 power. So we'll do that. And then we can move the 1/2 in front using the natural log rules or the log rules. And now we're ready. So we've done essentially a whole bunch of algebra. These first 1, 2, 3, 4. These first 4 steps are all just algebra steps. I guess 5. This is also, well, this is, maybe a trig step, I don't know, whenever you learned the natural log value. So that could be a trig step, algebra step. You could have learned it in algebra, whatever. Now we're going to take our first calculus step. We're going to take the derivative of this. So the derivative of natural log of something is 1 over that something times dy dx, essentially. So this is going to be 1 over y times, you can put y prime, which is my preference, but question is looking for dy dx, so I'll do that. All right, so this is equal to 1/2 times, we've got 1 over this whole thing, so 1 over x to the 4 minus 1. And then we need the chain rule for this, right? So in order to do the chain rule, we multiply by the derivative of what's inside that natural log. So the derivative of that is 4x cubed, and then derivative of -1 is just 0. So that's what we have there. So we still have this 1 over y times dy dx. And that's going to equal, well, the 2 and the 4, this becomes a 2. So it's going to be 2x cubed over x to the 4th minus 1. But we're asked to solve for dy dx, not 1 over y times dy dx. So we're going to multiply through by y. And then we can substitute our y, if we so choose. So that whole thing, which we've already established is root x to the 4 minus 1. So that's root x to the 4th minus 1. And then we'll multiply this by 2x cubed. And this is actually root x to the 4th minus 1 quantity squared, right? So now we can cancel these. Cancel this and cancel the 2. So our final answer is 2x cubed over root x to the 4th minus 1. And you can just take the normal derivative of this, and this is what it should come out to be. Provided that you just changed it originally. So if you changed what we have here to equal that root x to the 4th minus 1, it should be a pretty easy procedure to get there. Probably even easier than what we have here. Usually we use the natural log to make things a little easier, but this had kind of a simple step already, so this is actually probably a bit more complicated. But at any rate, that's what the question asked for, so that is what we did.